All right, so there's going to be one topic that overlaps from the last quiz that we took and this test, and that is our word problems here. So remember, for our word problems, we use that formula. A is equal to our principal or our starting amount, so that would be little a. Times 1 plus our rate to the power of t. So we need to find our starting amount, our rate, and our time. So in the first year, the Travis Scott concert had an attendance of 500 people. The attendance increases by 22% each year. How many people will attend in the 5th year? Round your answer to the nearest person. So what's our starting amount? What's our A? 500. What's our rate? 0.22. Perfect. We just move our decimal place 2 times, so 0.22. And then what's our time? 5. So we have A is equal to our starting amount times 1 plus 0.22, so 1.22 to the power of 5. Then we can just put this into our calculator. So we have 500. First thing we have to do is our exponent. So 1.22 to the power of 5. And we get 2.7027. And then we just multiply that times 500. So we end up with 1,351, and it says round to the nearest person, so that would be a whole number. So this many people. So we had questions like this on our last quiz. You'll have one like this on the test tomorrow. And you won't have any graphing ones, so you can ignore number 1 and 2. You will not have any questions that have to do with graphing on your test. One thing that I wanted to point out about the review is that it's missing 7.5, but your test is going to have 7.5 on it, so just make sure you know 7.5 homework. I did a video of all the questions from 7.5 homework. It's on YouTube, and I posted the PDF of the answers. So also, when you're reviewing, review 7.5 as well. So let's look at number 5. Here we are rewriting each equation in exponential form. So it's given to us in log, we need to put it in exponential. So what is our base? 2. What is our exponent going to be? -2. And then what's that equal to? 1/4. Perfect. This is our base. That's where we start. And then we just switch the position of the other 2. Number 7. What's our base? 15. What's our exponent? 1. And what's that equal to? 15. Perfect. This is our base. And then we switch these 2. Number 9, here we're putting it into logarithmic form. So we start with our word log. What's our base? 16.
Miss Pepper,
Yes.
can you do number 6?
Yeah, I'll go back. What comes next? 256. And then what's that equal to? 2. Perfect. So always start out with your base and then just switch the other 2. All right, let's go back to number 6. Well, this is a good one. What's our base when it's not written here? 10. So what's our base that we start with? 10. And then what's our exponent? So remember, we switch these 2. So 10 to the power of 0, and what's that equal to? 1. This was good. So remember, when your base is not written, it's implied that it's a base of 10. that was number 6. Let's go back to 11. So we start with our word log because we're putting it into log form. What's our base? 324. What comes next? 18. And what's that equal to? 1/2. Perfect. Any questions on this section? All right, so the next ones, we are evaluating the log. On your test, you're going to say evaluate each expression without a calculator. These you cannot use a calculator for. But we're going to say log base 14 of 16 is equal to some value x. So we want to put this into exponential form because it helps us solve. What's our base? 4. What's our exponent? X. And what's that equal to? 16. So 4 to what power gives us 16? 4 to the power of 2. So x is equal to 2. That's your answer. Now let's do 15. So log base 2 of 64 is equal to some number x. What's our base when we put this into exponential form? 2. What's our exponent? X. And what's it equal to? 64. So 2 to what power gives us 64? Let's figure it out. If you don't know right off the top of your head, we'll figure it out. So let's just start with 2 to the 3rd power. That's 8. 2 to the 4th power would be 8 times 2, so 16. 2 to the 5th power would be 16 times 2, which is 32. 2 to the 6th power would be 32 times 2, which is 64. So 2 to the 6th power. So what's x equal? 6. So if you don't know right off the top of your head on the side, work it out. Do you guys have any questions on this section? So going back to number 10, we are rewriting it.
Wait, I'm sorry, I'm at number 26.
Okay, 26. All right, next page. Condense each expression to a single logarithm. So the first thing we want to do when condensing or expanding is we want to figure out our exponent. So if we have a number out front, we bring it to the top. If we have a number up top, we bring it to the front. So here we have numbers out front. So we're going to make these our exponents first. So this is going to be log base 8 of 10 to the 4th power minus log base 8 of 7 to the 24th power. Now to condense this, when we are subtracting, what do we do? Divide. So log base 8, that stays the same. Whatever your log and your base is, stays the same, but we're condensing it to a single one, so we only write one of them. What goes on top when we divide? 10 to the 4th power. Awesome. The first one always goes on top. So 10 to the 4th power divided by 7 to the 24th power. And you would just leave your answer like that. All right, let's look at 19. This one's a little bit tricky, which we would probably see this as 5 log base 3 of 11 plus 1/2 log base 3 of 7. So it would look like this on the test if you had one with a fraction, not like this. So it would probably make a little bit more sense when it's just 1/2 being multiplied out front. But what should we do first? Move the 5 up top and do the same thing with the 1/2. Move it up top. So log base 3 of 11 to the 5th power plus log base 3 of 7 to the 1/2 power. Now to condense it to 1 log. If we're adding, what do we do to condense? Multiply. So this would be 11 to the 5th power times 7 to the 1/2 power. You can just leave it like this. You don't have to figure out what 11 to the 5th power is and multiply that times 7 to the 1/2 power. Just leave it like this. So in 21 through 24, we're expanding. So this is log base 7 of w to the 4th power, and then u. How do we turn a square root into an exponent? What's the square root of u? But if we put it as an exponent? Square root is the same thing as saying, awesome, a fraction, so 1/2. Now to expand, we're doing the same thing, but in the opposite. So if we're multiplying, how do we expand these? Before we do that, we want to expand it. So if we're multiplying, we add. So log base 7 w to the 4th power plus log base 7 u to the 1/2 power. So to expand, when multiplying, we add. So it's the same thing, but just going the other way now. And every time you break it apart, everything needs its own log. Now we deal with the exponents. So what do I do with the 4? Put it with the log. We bring it to the front. So just like in the other ones where I took what's out front and put it to the top, for these I take what's on the top and bring it to the front. So I'm just going in the opposite direction. So I have 4 log base 7 of w plus 1/2 log base 7 of u. And that's my answer. So I'm expanding here. All right, let's do 23. So again here, I'm multiplying. So how do I expand? We add. So log base 9 of x plus, every single time I break it apart, I need to add a log in there. So log base 9 of y plus log base 9 of z to the 5th power. What else do I need to do? Move the exponent. Awesome. So I'm going to take this 5 and just bring it to the front of that log. So this is my answer. Okay, I'm going to do 22 and 24 also because they're a little bit different. So here, I have a 5 as my exponent on top to start with. So when I break this apart, before I do, I can either distribute this to both things on the inside, or I can just move it to the front. So I'm going to move it to the front, so it's log of 7, log base 7 of x times y to the 6th power. Now I'm multiplying, so how do I split it apart when I'm multiplying? We add. So this is 5 log base 7 of x plus 5 log base 7 of y to the 6th power. So just notice how this one's a little bit different. Because this 5 was affecting both of these, when I break it apart, I need to have that 5 in both of them. And now what else do I need to do? Move the 6 up front. So if I already have a 5 out front there, what do you think's happening to the 5 and the 6? I multiply. Awesome. So this is my answer. Okay, 24. So I have log base 6 of 5 times the cubed root of 3 times 7. So this is log base 6 of 5 times the cubed root of 3. So I'm changing the cubed root to be an exponent. But it's also affecting the 3 and the 7. So 7 to the 1/3 power also. So because both the 3 and the 7 were under that cubed root, I need to apply it to both of them. Now if I'm multiplying, how do I expand this? I add. So log base 6 of 5 plus log base 6 of 3 to the 1/3 power plus log base 6 of 7 to the 1/3 power.
Miss Carver,
Yes.
do you have to change the 1/3 power?
Yes, because if you didn't, it would be like the cubed root of 3. And then we wouldn't be able to bring that to the front like we do here. So we have to move this to the front because we only want one thing in our log. So you need to change it to an exponent to bring it to the front. Because once it's up top, then you just bring it to the front. So you need it as an exponent, so it's up top. So here we have log base 6 of 5 plus 1/3 log base 6 of 3 plus 1/3 log base 6 of 7. So notice how each log just has one number behind it. So log base 6 of 5, log base 6 of 3, log base 6 of 7. That's our goal, is to just have one number, one term behind each log. So if you look here, we just have an x behind the log. We have a y behind the log and a z behind the log. So we just want one thing behind it. So that's what we have to do when we expand it. So if you have 3 to the power of 1/3, you need that exponent to go to the front, so it's still just 3 behind our log. Okay, let's look. Any other questions on those 21 through 24? All right, 25. So use a calculator to approximate each to the nearest thousand. For these, we're doing our change of base formula. So we have a log on top and a log on the bottom. Which number goes on top? 22. Awesome. The one that's already on top stays on top. The one that's kind of down low goes down low. So we need to figure out what the log of 22 is and the log of 4. So the log of 22 is 1.3424 divided by the log of 4, which is 0.602059, and then we divide these two. So we end up with 2.229. On the test, it'll say round to the nearest 3 decimal places or the nearest 2 decimal places. This one says the nearest thousand, so that would be 2. So 2.23. But in all the directions, it'll either say like leave as a fraction or round to the nearest decimal place. All right, let's do 26 also. So we have a log on top and a log on the bottom. Which number goes on top? 10. And then what goes on the bottom? 2. So we would put the log of 10 in our calculator, which is 1. And then the log of 2, which is 0.301029, and then we divide. So 1 divided by our decimal gives us 3.32. Oh, here you go.